It's been a whole term and I still don't know what a carbon is.
The hell is a bond?
And what is this O doing in the middle of this triangle?
Yes!
Hello, chemists. I am chairchair.
Wow, whoever made you must have used a lot of model kits. And you don't even look remotely like a chair.
Did someone sit on you? Poor thing.
Quiet! In order to escape this room and /or pass tomorrow's Orgo final, you must answer these 3 synthesis questions just because I said so.
Did somebody say Orgo? It's a sin to me.
Quiet! Yes, I know it's a sin to be anti. This is no time for memes.
Okay, so it looks like we need to get rid of this bromine and add on 2 alcohols.
Oh hey, that looks like dihydroxylation, which requires...
I think it's OSO4 peroxide and an alkene, right?
But where are we supposed to get an alkene from?
Well, let's write down what we have first. So we need an alkene and OSO4 and peroxide. Right, an alkene. Looks like an E2.
But is it side-sev or non-side-sev?
Well, I think we need the double bond to be over here instead of over here, which means we'll need to take the beta H from the carbon that has more H's, which is this one.
Wow,
so that means non-side-sev. Great.
But what do we need for non-side-sev?
Non-side-sev only happens with big bases. Let's use my favorite, LDA.
Oh, good laddie boy.
So LDA, we would start with this bromine and make LDA. I think we just did a retrosynthesis right now.
Wow, we
All
know
right.
Orgo?
Okay, I think we have the whole solution, right, Hillary?
Yep.
All right, let's write it out. All right, our starting product with LDA puts the double bond right here. Then, if we use OSO4 and peroxide, we get the alcohols. But because they both add sin, we have 2 different solutions, just like it says in the product.
Oh hey, that wasn't that bad. Okay, last question. So we have a benzene with a methyl and an alkyne, and then we have this weird triangle with an O in it.
I remember now, that's an epoxide. But what's that pH? I don't see it on the periodic table.
Oh, last time I saw it was on the acids and bases test, so no!
Oh, that's a phenyl group, which is just a benzene.
Okay then. But how do you get the epoxide?
With MCPPA and an alkene.
What kind of alkene is it?
It's a cis alkene, because the H's are in the same direction.
It's just like the last problem. We need to use Lindlar's cat, right?
Alrighty, so how do we get everything together?
Well, we have to add it to the alkyne that we have. And we add from both sides. So, with the alkyne that we start with, we can use either sodium and liquid ammonia or H2 Linlar to make it into an alkene, because that's basically the same thing. So I'm just going to go with sodium and liquid ammonia. So with the alkene that we have, like in the last question, we can do a haloacid addition and make it into this thing. So again, using the alkyne that we start with, we first have to deprotonate it, and then we can add this thing that we made here onto one of the ends of it. So then we get this. But then, like, the final product has a phenyl group, and we start with a benzene. So wait, this doesn't have a bromine on it. But from here, using what I know from the radicals unit, we can just add Br2 and light and add a bromine onto the end of this.
Wow!
And then going back to what we made the step before, we can just, this isn't here, we can just deprotonate the other side of it.
And do an SN2!
Exactly!
We're almost there, Marie.
Okay, so now we have this, right? But then using what we did in the retrosynthesis, we know this just goes to H2 Linlar to make the cis alkene. Running out of space. Great. Yeah. And then from here, we just use MCPBA and make the epoxide.
Woo! You finished!
Take that, you stupid chair!
I
So if H2O is water and H2O2 is peroxide, what's H2O for?
What?
For drinking.